Well, good afternoon or good morning, whatever time of day you're looking at these notes. I'm going to run through radians and degrees, section 3.2. We've covered 3.1 for 2 days, and now we're going to look at 3.2, which we'll go back and review a little bit of the radian measures, definition of radian measures, practice some conversions, and then practice with some equations of radians only. So here we go. In a circle, a central angle that cuts off an arc of equal length to the radius of a circle has a measure of 1 radian. In other words, this arc has to be the same as this radius, and that's going to tell me what 1 radian measure is. Now, 1 full rotation around the circle is 2 pi radians. 180 degrees is 1 radian. So 180 degrees is equal to a pi radian, and 360 degrees is equal to 2 pi radians. Okay, so to find the measure, the radian measure of any central angle, we must first find how many radii are in the arc it cuts off. To do so, we divide the arc length by the radius of the circle. If the radius is 2 centimeters and the arc cut off by the central angle theta is 6 centimeters, then the radian measure is 6 pi divided by 2, or 3 radians. And here's the formula that we're going to use. We're going to know that theta, or the angle, is equal to the arc length. That's what the S stands for, arc length, over r, which is the radius of the circle. And that's going to tell us what the angle is, what 1 radian is. Okay, so we'll want to remember that particular formula. So a central angle theta in a circle with a radius of 3 centimeters cuts off an arc length of 6 centimeters. What is the radian measure of theta? So remember that theta is equal to the arc length divided by the radius. So our theta, our radian measure, is equal to the length, which is 6, divided by the radius, which is 3. So it looks like that our angle is 2 radians, is equal to my theta. We've talked about that last in our first exposure to section 3.1 in our last packet. So I wanted to do 3.1, 3.2. We're actually transitioning books. So that's why there's a little bit of an overlap here. We have talked about converting, so it's okay that we're looking at it again. So if I ask you to convert 45 degrees into radians, again, there's 2 different ways you can do this. If you know that my degrees, so we said that 180 degrees is 1 pi and 360 degrees is 2 pi. So if I know that I have 45 degrees, I have 45 out of the 180 to make 1 pi radian. So therefore, again, the 2 different ways I could do it, I know that there will be 4 of these to make 180 degrees. So if I have 45 degrees, I know that is 1/4 of a pi in radians. The other way I can do it just by calculation is put 45 degrees over 1. And then I need to divide that or multiply it. I'm dividing it by 180 over pi, which the reciprocal is 100 pi over 180. So what I'm going to do is do a little bit of simplification here. And I know that I've converted then. It is 1/4 of a pi. If I do 450 degrees, again, I need to know I've been all the way around the circle once. So if I am thinking along those lines, let me pull this calculator up again if you wanted to use it. 450 degrees minus the 360 degrees to go around the circle twice is 1 time all the way around and then a half of another pi. So if that's true, you've gone 2 pi when you've gone all the way around that circle to 360 degrees. And then you've gone 90 more degrees, so that's another half of a pi. So I'm going to add another 1/2 pi. Now we call it pi halves, but it's really a half of a pi. So if I have 2 pi and add another half pi more, I have 2.5 pi, but you won't see that very often written in that method. So we're going to change it back to an improper fraction, and 2.5 is the same thing as 5 pi halves, or 2.5 pies. This is how it's properly written in trigonometry, so that's why I wanted to make sure that you're aware of that. If I do negative 150 degrees, well, I suppose I should show you this one just by the plug and chug method as well. So it's 450 over 1 times pi over 180. So the zeros will go out, and then I reduce the 45 and the 18. So 9 will go into both of those. 9 goes into 45.5, and 9 goes into 18.2. And so that's where I get the simplification of 5 pi halves, just by what we call as math teachers, just a plug and chug. Put it in and crank it out. If I go to a negative 150 degrees, let me put this down. If I go to a negative 150 degrees, if you're just going to do calculation, it's pi over 180 degrees. So the zeros are going to go out. I'm going to be left with a pi. Now, how many? Let's see. 3 will go into both of those. So 3 goes into 15 5 times, and 3 goes into 18 16 6 times. So I have a negative 5 pi sixth. If I think about it in terms of where I am, a negative 150 degrees, remember it's going to start here and go the other direction. So 150 degrees means you have 30 degrees left to go. So if you have 30 degrees left to go, you have almost been the whole 180 degrees. So I've gone 150 out of the 180. And so this is the exact same thing that I've done, just in a little bit different method. So 3 goes into both, 5, 6. I have to know I went the negative direction. So you've gone negative 5/6 of a pi, which is, either way, I don't care which way you do it, but whatever's most efficient for you. Now, converting to degrees. So if I'm going to convert to degrees, I can think of my circle. All the way around the circle is 2 pi radians. 180 degrees is 1 pi radian. So if I've done pi 6, that means I've gone 1/6 of 180 degrees. So if I do 1/6 of 180 degrees, it means that I've gone 30 degrees. If you want to see the just how we actually crank it out, it's pi 6 times 180 over pi. So if I want to get rid of the radian, I have to make sure that my pi cancels out. And this is where this turns to 30 degrees. So pi 6 is 30 degrees. And in our next unit, we're really going to try and hammer being able to talk about our unit circle either in degrees or in radians, and go back and forth between the two of those. So if I, letter B, if I get to 4 pi thirds, it means I have 1 1/3 pi. And I think you'll see that this goes pretty quickly once you realize what's happening. So you have 1 whole pi. So there's my whole is 1 pi, 180 degrees, plus 1/3 of another 180 degrees would be 60 degrees. So if I'm trying to make sure that I get this is my 180, plus the third more is 60 degrees, and so my total would be 240 degrees. Again, if you don't like that, it's 4 pi thirds times 180 over a pi. My pi's will go out, my 3 will go into 180 60 times, and 60 times 4 is 240 degrees. Again, if we were in person by this point, I believe we'd be able to do this without using the formula, but since I don't see you every day, I haven't been able to practice this with you every day, but here we go. So last part, if I have 3 pi's, that means that I've gone 180 degrees 3 times. So 3 times 180 degrees would tell me that you are at 540 degrees. Not sure. Well, yeah, we could do it this way. 3 pi over 1 times 180 over pi. My pi's will go out, and 3 times 180 is where I get the 540. Not something I would have thought of very frequently, but that's how that one's going to work for us. The next part is asking you to find the exact values. Now, we've already talked a little bit about this. So if I'm looking at my unit circle, I'll put these up just another time. So if this is my 30, and again, I'm really only interested in my first quadrant because they're the exact same thing all the way around according to my reference triangles. So we'll go 30, we'll go our 45, and then we'll go our 60. All right, so I usually like to try and get those in order so that I know. I don't want green. I wanted the black one. So I know that when I put these in order, and the more you write these, well, it looks like, oh, come on. Could I save, create my color palette? Okay. I just like to do the same thing 10 times in a row. I do. I really do. Let me erase this. Okay. And my drawing. There we go. Okay, so here's what we knew that we had. So for 30 degrees, I've got root 3 over 2, 1/2. For 45, I have root 2 over 2, root 2 over 2. And then for the 60 degrees, I have 1/2, root 3 over 2. All right, so if they're asking me to do the sine, tell me the exact value of sine of pi 6. I have to know that if I've gone, and this is my pi, so this is 0 and 2 pi. So if I know that I've gone a sixth of the way, 30, 60, 90, I know that 30 degrees of it is 1/6 of the pi. And if I want the sine of pi 6, then I know that I need this value, which is 1/2. If I wanted to know what 4 times sine of 7 pi 6, remember that 7 pi 6 would be 1 whole pi plus 1/6 more of a pi. And if you're 1/6 more of a pi, I have to know where you are. So if you've gone 1 pi, remember that you've gone all the way from here and you've gone 1/6 more of a pi. So you've gone 30 more degrees down. So that means you're here with a 30-degree reference triangle. And your 30-degree reference triangle, then remember you're in the third quadrant, is going to be a negative 1/2. So you have 4 times a negative 1/2, and that's going to tell you that your exact value is negative 2. Okay. And then lastly, a negative cosine of pi 4. So to go to pi 4, remember I'm at 45 degrees. That's what a fourth of a pi is. There's 1, 2, 3, 4. If I were to go all the way to my 180 degrees of my pi. So a fourth of a pi is 45 degrees. So I know that this pi 4 of cosine is a negative square root of 2 over 2. And so I just need to make sure I give the sign negative root 2 over 2. And those are the exact values. Okay. The last couple of examples, 5, 6, and 7, are asking you to do some evaluations and understanding what pi 6 actually is, or when I put them into an equation, actually to do some simplifications. So they're telling me that x is equal to pi 6. So I have 4 sine of 2 times pi 6 plus a pi. Okay, well, for me to simplify this, I have a 4 sine This one is pi thirds plus a pi. So a pi plus a third of a pi would make 3/3 plus 1/3, which would tell me I would have 4 times the sine of 4 pi thirds. All right, fair enough. So what I need to know is what's the value of 4 pi thirds. So I know that I have 1 whole pi plus a third more of a pi, which would put me into the third quadrant. And if I'm in the third quadrant, my value of 4 pi thirds would be a third of the pi, which would be, if I look back to here, my 30 degree, the sine of this particular piece, so cosine and sine, would be a root 3 over 2. So if I'm in the third quadrant, I have 4 times a negative root 3 over 2. And then the rest of it just becomes simple algebra. I'll multiply that by 2. And so I end up with negative 2 root 3 as my value. Kind of nifty, huh? So they seem really complicated, especially if you were to see these on a standardized test, but they're really not that bad. On to the next part. So we're asking you to evaluate the sine of x minus pi halves when the x value is equal to pi sixths. Okay, so we're going to say we have the sine, and they're telling me x is now pi sixths. So I have a pi sixths minus a pi halves. And the first thing I want to do is simplify this little piece. So pi sixths minus pi halves, I need a common denominator, remember? So I'll need to multiply both of these by 3. So this is actually 3 pi sixths. And so if I have pi sixths minus 3 pi sixths, I know that my sine of 1 minus 3 is a negative 2 pi sixths. Well, I can reduce that even farther. So I have now the sine, of a negative pi thirds. So I need to know what the value is of a negative pi thirds. So if I want to know what a third of a pi is, again, I go back and take a look. A third of a pi would be 60 degrees, and I'm looking for the sine. So the sine of 60 degrees is root 3 over 2. So if I'm at root 3 over 2, and remember I'm at a negative, so that's going to put me down here in the fourth quadrant. So therefore, this value would be a negative. So all of these things I've got to keep straight. So what I actually have is the sine of a negative root 3 over 2, and they wanted the opposite of what that value is. So therefore, what I need to know is it's the opposite of the negative, which is going to tell me that this is going to be a positive root 3 over 2. And finally, the last one I'm looking at is can you find the value of y that corresponds to each value of x? And then write your results as an ordered pair xy. So what I'm looking at, I have x is equal to 0, x is equal to pi halves, pi, 1.5 pi's, and 2 pi. And then they want me to take that value and then multiply it by a half. All right, so I have to do this particular problem 1, 2, 3, 4, 5 different times. And it seems like it's going to be kind of daunting, but it's not. So they're asking me for the cosine at 0 degrees, at 90 degrees, at pi, at 1.5 pi, and then back to 2 pi. Well, all I need to know are what are the coordinates. All right, well, this one's 1, 0, this one's 0, 1, this one's negative 1, 0, and this one's 0, negative 1. Remember that they're in the order of cosine theta, sine of theta. And then that makes my job really easy. So they're asking me to put them as ordered pair. So if my x, the first one, if my x value is 0, and I put in 0 degrees, so the cosine of 0 degrees, is going to be 1. and then 1. So this value is 1, and then I have to multiply it by a half. So my ordered pair would be 0, 1/2. If I put pi halves in, so now I have cosine, or a half, times the cosine of pi halves. So the cosine of pi halves, I'm now here at 90 degrees. That's what my half of a pi is. Remember that the cosine sine, so the cosine of pi halves is 0. So 1/2 times 0 would be 0. So at pi halves, you would be at 0. The next one is 3 pi halves. So I missed it, pi. So at pi, remember I'm at a negative 1, 0. Cosine is negative 1. So negative 1 times a half is negative 1/2. To finish this up, let's get the 3 pi halves. So the 3 pi halves is 1 pi and half of another. So the cosine and sine, the cosine is 0. So 0 times a half would tell me that this value is 0. And then lastly, at 2 pi, so 2 pi, your coordinate is 1, 0. So cosine is 1. So 1 times a half would tell me at 2 pi, you're back at a half. So at every interval that we go to, if we were at 0, 1, negative 1, 0, 0, negative 1, depending on how many times I go around the circle, the y coordinates are going to be the same, even though the x coordinates are going to change. Questions. Now these are ordered pair, so if we were to have time to do some graphing, we would use these ordered pair to do the graphing of a trigonometric function. Okay, that's the end of chapter 3, section 2. I'll upload this and move on to the next section. Oh, hold on, before I stop you, I was going to show you where your homework is. Okay, so I'm going to zoom on down through your packet. This first page is your homework from section 3.2. So we are asking you to find the exact values. You may have done that in the other packet. I believe you had done, is this worksheet 2? No, it's worksheet 2. So I don't think that you have done this one. So make sure you do that one. There are some more, the notes that came out of that first packet that you had. Those are all here. Again, if you want to read more about radians, those are all there. Let's see if my mouse will go a little faster for us. Okay, and then this was your first day's homework from your previous packet. And then there is a review in there. So identities we did not do, and I'm very sad about that because I love those. But let me get you on down here a little farther so I can show you what your homework is. If you have a chance to read through the identities, you may want to do that. These are all things having to do with your identities, so nothing that we're doing right now in our homework. Okay, so when you get down here, you're going to see that this is section 3.1. So once we start this particular section, the first part of our lesson for today said to do 3.1, 1 to 73, every other odd. This is what we mean by that. So this is your Wednesday homework, or Thursday, depending on which class you're in. So Wednesday, this is the Wednesday, Thursday. Now, I'm going to go ahead and give you 2 parts to that. So not only do you have that first worksheet, but you also will have this one as well, section 3.2. It is 1 to 73, every other odd also. So this is a Wednesday or Thursday homework also. Just because we're running out of time, you'll have the weekend to get this done. I know it's a little bit longer. And then on Monday and Tuesday, I'm going to get you to 3.3. the definition of circular functions. Hopefully we'll have a little bit of time to get that in, but your 3.3 homework will come from here. Circular functions, even or odd. So this will be next week. It'll be your Monday, Tuesday homework, which will be your last one of the year. So this will be your Monday, Tuesday homework. Okay. All right. If you have any questions, let me know. I'll be happy to clarify things for you. All right. You're doing a great job. Keep it up, everyone.